Alright, hey guys, I'm Katy. So for this lesson, we're going to do with this format because I have sports and we're actually going to do it next Monday as well. So just bear with me. However, our Discord is still going to be open for questions. Other teachers are still going to be able to help you. So if you have any questions, put that in the help channel. Alright, so let's get started, and this is our lesson 3, which is what is the internet, and we're gonna look at we're gonna actually go into detail about how that internet actually work, and how our devices receive information from other device or from the server. We're gonna look a little bit of the internet history. So it started in 1969 when the U.S. military acquired 6 university supercomputers, and it created this thing called Arpanet. So remember, at that time, computers were gigantic computers that take up the whole entire room. So that's what the supercomputer means. And when we wired these 6 computers together, we created this Arpanet that can send messages from one to another. Yeah. And then in 1970, smaller colleges nearby kind of connect to the computers, and the original 6 computers were called the backbone of the computer network, and the small computers kind of just join in and act as the routers for the whole entire internet. And then in the 1980s, your bigger corporate research departments that link to the public network facilities. So by 1980s, the internet is now public. When it was at its research phase, which is the 1969 phase, the 6th university, it was a private research military internet, but now it's public for everyone to use. And then private commercials network and global links bring the network everywhere. And this is when the internet started, not only in the US, well, at every single point in time, the internet was happening everywhere, but we're just looking at the US internet network right now, and then we're going to look at how the internet connects the whole entire world later in the lesson. So now we're just going to go briefly over the internet versus the World Wide Web. And the World Wide Web is also known as the www, which is the address link that you will see on the every single URL that you have. It's www.google.com. And so we're going to look at the difference between the World Wide Web and the internet. So the internet, like we just look at the map, is network of networks, which is a network of connected computers. And you can think of it as roads that connect towns and cities together. And the internet is what the World Wide Web works on. So the World Wide Web, which is also known as the web, is pages you see when you're on devices and you're online. So World Wide Web is a whole collection of websites or pages that you see when you open a Google browser. So it's google.com, it's facebook.com, it's youtube.com, and so on and so forth. So those 3 things and more are World Wide Webs, and they work on the internet. So the internet, you can think of it as roads that connect to towns and cities, And then the World Wide Web are the packages or the mails that are mailed to the towns and cities. And the towns and cities are your devices. And so, yeah. All right. And now we're going to briefly go over some terms and vocabs before we jump into how the internet works, because these terms and vocabs are going to come up, and we're not going to like interrupt midway to like talk about terms and vocabs. So we're just going to get over with. So the first thing that we have is the internet. So the title was wrong, sorry. So we're going to look at these 4 terms. Don't look at the title. So the first term that we have is Internet Protocol Address, which is also known as the IP address. And the second thing is Domain Name Service, which is DNS. And the third thing is HTTP versus HTTPS. And the last thing that we're going to look at is Uniform Resource Locator, which is also known as URL. So the first thing is IP address. So again, internet is a global network of computers. So each computer, each household has a lot of computers. And so each computer needs an identifier to let the whole entire world know that, oh, my computer is unique. And so each computer has its own address. And IP address make up of a total of 4 numbers from 0 to 255. So NNN means like 000 or 010 or 255. So from 000 to 255. And there's a series of 4 of them. And so, so each computer has its own unique address. And so that is how packets or servers know where to send the information to. So there are different versions of IP address, and the reason for that is because there are more and more computers made each day. And so IPv4, which is the one that I was talking about, the 4 sets of 3 digits, as you can see, is 1, 2, 3, 4, 5, 6, 7, 8, 9. This is, they kind of took out the 0, which also works. So it's like 1, 2, 3, 0, 4, 5, 0, 6, 7, 0, 8, 9. It actually is like that, but then they sometimes just take out the 0 for concising like the address. And so there are only 4.3 billion possible addresses, and as you can imagine, there are 6 billion people on Earth. Even if not everybody has access to the internet or has a device that has an IP address, each person owns like 2 or 3 devices. And so 4.3 is definitely not enough for all devices on Earth. And so we created IPv6, which is version 6, that has 128-bit address size. And so instead of 32-bit, which is 4 sets of 3 digits, it's way longer than that, and you have a lot more possible addresses. And this is created in 2012, so it has been here for 10 years already, and we're using IPv6 now since there are way more computers existing. All right, and a little more about Internet Protocol addresses. So IP address can tell you about your location. And we're just looking at the IPv4 because it's easier. So for IPv4, every digit or every set of digit tells a little bit about something about your location. So it's either like 172 that tells you about like your country or your region of the Earth or something like that. So I'm not quite sure about like which represent what, but it tells you about what location you are at. And so that's why VPN works, because VPN links your device to a random IP address that is outside of your country, your region, or whatever. And so when you watch Netflix, you want to use VPN to link yourself or your device to like a Australian IP address, and so you can access Australian Netflix series. Yeah. All right. And so now we're gonna look at domain name service. Domain name service is really cool because it links or it assigns your IP address to a unique domain name. So IP addresses can host websites, and so that means that we can get a website from just knowing the IP address. So that means that my computer has a unique IP address. It can host websites, and so you can access my website from just knowing my computer's IP address. However, we have to know so many IP addresses then to like access all the websites that we want to access, and so that's kind of impossible, right? So we use domain name service, and domain name service works by assigning a IP address to a unique domain name. And so imagine a phone book. We have names on the left side and then phone numbers on the right side. So we have phone numbers on the right side, and so if you turn that into IP address and domain name, it's IP address on the right side and then domain name on the left side. And domain name is google.com, netflix.com, instagram.com, spotify.com, nasa.gov, and youtube.com. And for bigger servers or websites, we need multiple IP address to store all the information. And so YouTube has way more IP address than just a small website. And so Facebook actually also has a lot more IP address than just one, Google as well. However, websites like I don't know, I can't really think of a small one right now, but smaller websites, more local websites need less storage, and so you need less IP address. And youtube.com also has a lot of different services, like let's say google.com has Drive, has slides, has docs, has forms, like forms.google.com, etc. So it's reasonable and understandable to have different IP address for that, so many different services. All right, and now we have the HTTP and the World Wide Web. So again, World Wide Web is a higher level of abstraction. It runs on top of internet, so it works on the internet. And the World Wide Web is the mostly used service in the world, or service on internet. Sorry, and so the application protocol is something that transfer web to your device, and the difference between HTTP and HTTPS is just that HTTPS is secured, so the S stands for the word secured, and so this is just the secure version of HTTP. And then when you type in Instagram, it's HTTPS and then worldwideweb.instagram.com. And so if we just break down the URL, HTTPS, when you see the S, that means that it's secured. Your data is most likely to be protected or more protected than HTTP, so you can be more comfortable or rely more on HTTPS than HTTP. So whenever you visit like a website with only HTTP, you shouldn't put in your personal information, if that makes sense. Yeah. All right, so now we're gonna get into the core of the lesson, which is how does it work? How do we connect to the website? So now we know all the terms, we're gonna dive right in. So this is you, and you own many devices, like I said earlier. Every people owns like more than one device, or usually. And so you have Alexa, you have iMac, you have iWatch, you have iPhone, you have iPad, you have Kindle, you have the school Chromebook. So let's say you're watching a YouTube video, and this video is stored in the Google data center in Belgium. So Google has many different data centers, and let's say that the Minions song, Happy Birthday song, is stored in the Belgium data center. So how do we get the data from Belgium? Like I said earlier, there are many, many different Google data centers, and how exactly, if we know that data are zeros and ones, how do we get those zeros and ones from Belgium across a whole entire Atlantic Ocean? So how does it work? One, we could use a satellites. As we know, satellites are up in space. We could use satellites and send those zeros and ones through electromagnetic waves. We could do that, but it's not realistic because satellites are 22,000 feet above the ground, and so it's going to take almost 50,000 feet to just reach you. So one, it's not realistic because there are a lot of like disruptions. There can be debris flying over, and so disrupting the data signal, or something might be in the way. And so one, it's not realistic. Two, the delays, which is the time that it takes, and the data latency, again, is the delay, which is the time it takes, is not tolerable for many apps. Apps demand data in a certain amount of time, and so the time that it takes to travel that much distance is not tolerable for a lot of apps. So instead, we use this thing called optical fiber network. So optical fiber network are physical networks that go across the ocean, over mountains, and through many different types of terrain. So again, I just stress this, it's physical networks. So there are actually physical wires that you can see with your eyes, and they're quite big, running through or running across the ocean, over the mountains, and many different terrains. So this is the projected map of the optical fiber network in 2023. And as you can see, it mainly connects through the ocean, and on land, on land, there are different ways that we can go about the network transmission or the data transmission, but the optical fiber network is the main way that we go across the ocean. Alright, so optical fiber network are cables made of glass. Obviously there are rubbers around the glass, but they are glass and they are physical, and so they lie on the bottom of the ocean or run across the Atlantic Ocean. Glass, we use light are transferred through the glass fibers instead of electricity, because electricity, if it breaks, it's kind of bad. You have electricity running through water in the ocean, that's kind of bad. And so we use light instead. So if accidentally it breaks, it's just so that, the light can't go past anymore. And so the informations are through light signals, and 0 is light off, 1 is light on. So white glass, light can go through glass, and white light, light can travel the fastest. So another reason why we use light, other than safety reasons, are also that light goes the fastest. And yeah. Alright, so now we have a bunch of physical networks that are lying on the bottom of the ocean. Your devices may connect to the internet through an antenna cell tower or through a router. Ultimately, they're all connected to this backbone of the internet. So the cell tower that you see in your neighborhood, or the router in your home, they're all connected to these physical wires lying on the bottom of the ocean. So now our question is, how do we go from these cell towers, these routers, these home routers that we have, to these physical networks lying on the bottom of the ocean? So how do we do that? First, let's look at what's going on in the data center, and then we're gonna go look at like how it transfer those data through those wires on the bottom of the ocean and to your phone. So in the Google data center, we have physical racks that represent different IP address and different information or data that we have. And so Facebook, it's a really big website. It will take up the whole entire building of its own to store all this information. But for Google, it's made up of like a lot of small files, small websites, and so it just needs a lot of different racks to store a lot of different pages. And so within these racks or these data center, we have different racks that has different IP physical drives that stores website of different IP addresses. So as you can see in the animation, if you just take one out, it's the IP address of 192.16.52.6. Alright, and so now we're gonna go back to you. How do we retrieve that data from that one rack of information? So on your computer, you type in google.com into the Google web browser, and then like we mentioned earlier, the google.com really represent a IP address. And so this IP address is sent to the Google data center. So you type in youtube.com here, and then the DNS server helps you translate that youtube.com into whatever IP address youtube.com represents. And once we know the IP address, it is sent to the Google data center. So once the Google data center know what IP address that you're looking for, which is a website that you're looking for, it can send signals through the wire as shown in the animation to you. And so these signals are again represented by light signals because we're going through the optical fiber network, and it goes through all these different types of terrains, the mountains, the oceans, and to your local either cell tower or router. So companies like Google, Verizon, AT&T, they lay these optical fiber networks all over the world. That's why your home Wi-Fi network is most likely AT&T or Verizon. Yeah. And so now we're gonna receive those data. So the light signals that travels all the way across the Atlantic Ocean from Belgium, it reaches your local cell tower or your local router at your home. So it's like either or. So if it's sent to your local cell tower that you're trying to access with your cell phone, and then you turn off Wi-Fi and then only put on data, then you're trying to access that data from the cell tower. And so that cell tower sends data to your phone using electromagnetic wave. And those data is represented through zeros and ones. Or if you turn on Wi-Fi and then turn off your data on your phone, then you're trying to access those data through Wi-Fi. And so those light signals from the optical fiber network reaches your router, your home router, and then your router can either send wirelessly through electromagnetic wave, or you can use Ethernet cables that uses electric signals. So on the left, you can see the laptop is connected to the router wirelessly, and so it uses electromagnetic wave to send those signals to your laptop. And those waves have a certain range of area that it can cover, and so if you walk too far away from your home, you can't access Wi-Fi anymore. And then on the right, it's the Ethernet cable. So you can either wirelessly or you can use wire to connect to that data on your router. So the blue wire that you see is the Ethernet cable. And then we have the electric signal running through and then to your laptop. And those electric signals, like the light signals in the optical fiber network, they're all represented with zeros and ones. So now we're going to look at how the data were transmitted through the optical fiber network. Each file that you requested, which is either a website, a YouTube video, or any file that you want from the Google Data Center, it is break down into small packages. And each package has a size limit. Each package may arrive at a different time. Each package has a identifier, and then the data that is breakdown. And then so this diagram shows that the server, which is the server in Google Data Center in Belgium, it sends a package that is breakdown into 3. And so it sends to your data the first one, the second one, and then since the third one is missing, your data asks for the third one to be resent. And this is a very good animation of how it works. So again, we have all these files. Sorry, let me just replay that. Yeah, okay. I'll let it go back to where it was. So in the Google Data Center, we have, again, all these physical racks of information that we can store. And let's say we are trying to deliver this package to you. It is breakdown into multiple different small packages, and it will take the best route to you. And there are a lot of different networks or fiber networks that you can take, and each package take its best route to you, but ultimately it'll all reach your local cell tower, and your cell tower will send electromagnetic wave to you. Or it can reach to your home router, and that router can send either electromagnetic wave to you, or you can use an Ethernet cable. Okay. All right. So this is the last section. It's computers. So once our computer received those signals through either Ethernet cable electric signal or electromagnetic wave from the router or cell tower, those two signals, how do we break down those messages? So we're going to use this example of you sending an email to a friend. This is your computer, and then it goes through the internet, and then this is your friend's computer. So, like we mentioned in lesson 1, there's different layers of the computer, different components. The application means the application that you're running. So it is email.com, so gmail.com. And then it goes down to your TCP, your IP, and then your hardware. Hardware is the physical hardware on your device. So your computer, first, your gmail.com will tell your computer, okay, I'm sending a message. And your TCP will assemble those messages that you wrote on Gmail, and then it'll break down into small pieces of zeros and ones like we saw in the animation. And then your IP Internet Protocol layer will identify your friend's IP address, and then your hardware layer will convert all those information to binary packet and then sent through the internet to your friend. And so now your friend got those zeros and ones. So the hardware layer of your friend's computer will receive those binary packet data of zeros and ones. And the internet protocol layer, so we're going up instead of going down. So you're going down to your hardware layer, and then it goes to the internet, and now your friend goes up the application. So once the hardware layer receives those binary data, the internet protocol layer confirms that, okay, I am the IP address that it is directed to. It'll send those information up to your transmission protocol layer, which is the very important layer that assembles all those data. So, like I said earlier, packets can be delivered at different times, and so these small chunks of zeros and ones, it can be sent at different time at different order. And so transmission control protocol layer is what organizes those chunks of zeros and ones into a organized and complete messages or information that is sent up to your application protocol layer, which is your gmail.com website. And that gmail.com receives the information and be like, okay, it's a message from my friend. All right. So that is all for the internet lesson. That was a lot. And electromagnetic wave, I can't say that word properly. But this animation, I think, is the most important, which is how data are all sent to you. Again, it's small packets of zeros and ones, and then it is sent through the optical fiber network, which is physical networks, and it is sent to your local cell tower and then down to your phone. So in your Google data center or any data center, Facebook data center, whatever, they break down the small packets to you and to your cell tower. And the example that I had earlier, which is your device, your computer, it works this way as well. Instead of a building of servers, like of informations, instead is your data. So it's your data breaking down these packets and going through the optical fiber network, and then through the across the Atlantic Ocean or whatever ocean, and then to your friend's local cell tower, and then your friend's local cell tower sends electromagnetic wave down to her phone, and then she receives that information. Yeah. So, all right. So yeah, this is how internet works, and I hopefully you learned a lot, and thank you for sticking by until the end. And so yeah, make sure to do the quiz, as well as checking out the resource page. And then for lesson 4, we're going to look at machine learning and AI, and that will be taught by Grace, she's also a junior at Katy Academy. And yeah, so I'll see you guys soon. Take care. Bye.